In this final example, we're going to compare two box plots with each other. And the example that we're looking at is talking about the time it takes for a particular vitamin to dissolve. We're looking at two different vitamins. One is a generic brand versus the name brand Centrum. And the first question I would probably say is, in looking at these two box plots, which vitamin do you think has the greater dispersion? Remember, dispersion is talking about how spread out the data is. And for this, we probably want to look at range. So if we're looking at our Centrum vitamin here, I'm going to say that the range of this is roughly 2 to about 4.5. So the range on this one looks like it's about 2.5. Let's look at the generic brand. The generic brand looks like it's going from somewhere around 5 to, I'll call it maybe 8. So the range on this one looks like it is at 3. So just looking at min versus max values, I get an idea of the range, the overall range of the data. Another indicator of dispersion has to do with the interquartile range. And remember that the interquartile range is our Q1 to Q3. So look at the box itself. This is a wider box, right? So this box you can clearly see is somewhat wider than the box here for my Centrum, IQR. IQR entails 50% of the data, so we would also be able to say that because the IQR is going to have a broader range, then this data here would be more spread out also. So looking at dispersion, I'm looking at two things. For dispersion, I'm looking at range, and I'm also looking at the IQR, which is really another form of range. And so our generic brand would be the vitamin that has the most dispersion. The second thing we want to look at here is, in just reading this graph, maybe I want to try to understand which of the two vitamins is going to dissolve faster. So which one takes the least amount of time to dissolve? And we can just really kind of pick that out from looking at the graph. We know here that this Centrum vitamin only takes anywhere between 2 and 4.5 minutes to dissolve, whereas the time to dissolve for the generic brand starts at 5 minutes. So right away we know that that's going to be a Centrum is the one that dissolves faster. And then finally, let's see if we can determine what the underlying shape of each distribution would be. So the shape of the distribution. Let's start with our generic brand's shape. In looking at this box plot here, I notice that the median is slightly to the right of my data. However, the box itself looks to be evenly spaced within these lines. So an argument could be made that this shape of our generic brand is roughly symmetric or bell-shaped. I would probably say, if you wanted to argue, that this is slightly skewed, very, very slightly skewed left because the median's been moved to the right, you could have an argument for that. But really, I think it's probably going to be more of a bell-shaped distribution. If we look at the Centrum vitamin here, the shape of the Centrum vitamin, what can we see here? With our Centrum vitamin, if I look at the whiskers here, I have the left line and then I have the right line over here. I would say that the left line is slightly shorter than the right line, so I would say that we are slightly shifted to the left. And then it's not exactly that obvious, but I would say that my median is not quite in the center. It is also slightly to the left. So there's probably an argument here to be able to say that the underlying distribution for the Centrum vitamin is probably going to be more skewed right. And I understand that that's a little bit of a nuance there to try to understand those. These are really close to each other, but those are the things that we're looking at when we're thinking about shapes of distribution. You want to determine where the box is in relation to its whiskers is number one. And then you want to determine where the median is in relation to the edges of your box. And those things will help you determine the underlying shape of the distribution.